Section 3.2, this is really the same material as the first section or the first part of section 3.1 where we're graphing equations as a system, but in this case they're going to be inequalities. So instead of equal signs, we have inequality signs. We're going to graph them, and the thing that these graphs are going to have that the other ones didn't is shading. So for this top one, x is greater than 2. I always look at this and imagine it to be an equal sign when I graph it. So x equals 2. All right, this is going to be the line where x is always equal to 2. Switch to this. All right, so we have x equals 2. 2, 0 is there, and it's just always equal to 2. Whoops. Okay, so this ends up being a vertical line. All right, now when we graph this, since it has a greater than sign, okay, without the or equal to line underneath it, we're going to have a dotted line. Now we want to shade the part. Actually, let's hold off on shading for now. We'll come back to it. All right, the second graph, y is less than or equal to 2x minus 1, starts at -1, down 2 over 1. This one has that or equal to sign underneath it. Okay, so this is going to be a solid line. All right, so now when we shade these, let's go back up to the top one. All right, we have x is greater than 2. All right, we want to shade the side of this graph where everything is bigger than 2. Okay, numbers bigger than 2 are obviously where we have 3, 4, 5, etc. So this is going to shade to the right. All right, y is less than or equal to 2x minus 1. So for a problem like this, we can always plug in a point, pick any point, see if it's true or if it's false. If it's true, we shade that side. If it's false, we would shade the other side. An easier trick is just to look at this sign. Okay, it's a less than or equal to sign. Less than means it's below the line. Greater than means it's above the line. There's one exception which we'll get into later in the notes, but that's a quick trick that'll save you from having to do the math. So this is going below this line. Okay, and when you see or when you decide above or below, always imagine it from left to right. There's a guy on the left side of the line. Okay, below him is the ground, above him is the sky. All right, so the actual answer to this is where both graphs shade. Okay, so the red line we're shading to the right, blue line we're shading to the left, so they would overlap in that middle section there. For this next system, we have the first equation in standard form, so let's go ahead and graph this using the intercepts method. So for intercepts method, we're just going to imagine that the y equals 0, okay, which means it's not there. X plus 0 is greater than or equal to 3. I'm just going to pretend this is an equal sign for now. X equals 3. Okay, for the y-intercept, we do the same thing, except we pretend that the x equals 0. So 0 plus y, that's back again, is greater than or equal to 3. Y equals 3. Okay, so now we would just put each of those intercepts on the graph. X-intercept of 3, y-intercept of 3, connect them. This is a solid line because it has that or equal to sign there. Now, before we do this next one, let's just talk about how we would shade it by plugging a point. We can pick any point. An easy one is 0, 0. Okay, if we plugged in the point 0, 0, 0 for x, 0 for y, greater than or equal to 3. Okay, this is false. That 0 is not greater than or equal to 3, which means that this whole side is false. Okay, we would shade the opposite side. Okay, this whole side would be true. There's always one true side, one false side. Okay, we could still use that shortcut and just look at this sign, greater than or equal to. This is going to be above that graph. All right, back to the bottom equation. Point slope form, opposite, opposite. 1, 2 is our starting point. 1, 2 is right there. Okay, slope is 2 over 1, up 2 over 1. Okay, it's solid. Again, a solid line because that or equal to sign. Okay, it looks like this. All right, using that that shortcut, greater than or equal to, think above. There's a guy on the left side here. Above him is the sky, below him is the ground, so it's shading this way. All right, and we want to shade the section in the graph that's overlapped by both lines shading, okay, which ends up being this part right here. We would do this with nonlinear systems the same way we do it with linear systems. Linear means we have straight lines. Nonlinear means that it's changing or it's curved. So in this top equation, we have a V-shaped graph since it's absolute value. Okay, and we always want to start with the vertex, -2, -1. Opposite for the x, same for the y. -2, -1 is here. And then we look at the slope, which is that. Okay, it's going up 2 over 1. Positive on the right, negative on the left. All right, when we do the trick for this one, okay, we have greater than or equal to, that's above. Okay, above is going to be the inside for a face-up graph. Think of it almost like a cup or an ice cream cone. All right, so above it's the inside, below it would be everything to the outside, even on the sides there. The bottom one, we have standard form. Let's use intercept method. Pretend that y isn't there to get the x-intercept. X equals -4. Okay, so we are here. And then same thing for the y, except this time the x isn't there. This is back. So it's -2y equals -4. Y equals 2. All right, so we have x equals -4. We have y equals +2. Looks like that. Okay, this is going to be a dotted line because that sign here doesn't have the or equal to sign. So dotted line through those. Okay, now here's the exception I talked about before. Okay, if we look at this sign, it's greater than, it's above. Okay, but if we plug in a point, let's say we plugged in 0, 0. Okay, 0 for the x, 0 for the y, greater than or equal to -4. Okay, 0 is greater than -4. This side is true. This whole other side is false, which means this blue line is actually shading below it and not above it. All right, the reason that this is different is because of that y and the fact that it's negative. All right, let's come down here since I have some space. If we were to take that and we were to rearrange it, okay, so first step is going to be subtract x. Okay, we have -2y is greater than -x minus 4. Okay, this is what causes the sign to change here. When we divide by a negative, I'm going to do it on both sides here, this sign is going to flip around. Okay, so the only time when that above and below trick doesn't work is when we have a negative attached to the y. Because if we were to rearrange this in the slope-intercept form, it flips that sign the other way, all right, and actually becomes below. All right, so last step, we're looking for where these two overlap, and they overlap in this little section right here. This last one's a bit complicated because we're adding a third equation. All of our systems so far have been 2 equations, but in this next section, we start adding a third equation and a third variable. So in this system, let's do the top one first. This is in standard form. Let's just find the intercepts. Okay, we cover up the x, we get y equals 1. Same thing for the other one, cover up the y, pretend it's equal to 0, we have x equals 1. Right, so we have an intercept at x equals 1, intercept at y equals 1. Just looking at that, we can see the slope is going down 1 over 1, and we could really just continue that to get a better idea of what the graph looks like. This is a dotted line for this one because it doesn't have that or equal to sign. All right, so there's our first one. Second one, okay, let's say we rearrange this one instead. -x minus x, so -y is greater than -x minus 1. We have to get rid of that negative sign on the y there, so we're going to change all of these, and when we do that, we flip that sign the other way. Y is greater than x plus 1. All right, so it starts at up 1 over 1, okay, and then it's going up 1 over 1 for the slope. Okay, dotted line again. Okay, lastly, we have x is greater than or equal to 3. Okay, this is going to be the vertical line at 3. It's where x is always equal to 3. All these points here, x equals 3. This one is a solid line. All right, those are our 3 lines drawn. Now let's look at each of these. Okay, so for the top one, Okay, it's a positive y. We don't have to worry about switching it. Greater than, it's going to be above that red line. Okay, next one, middle one. This was greater than, okay, but that y is a negative attached. And we saw over here, it flipped the other way. That's not greater than here. That should be less than, my bad. So y is less than x plus 1. This one's going to be below this blue line. All right, and then lastly, x is greater than or equal to 3. Everywhere that x is bigger than 3 is to the right there. We're shading the part that it overlaps in all of these above the red line, below the blue line. To the right of that purple line is this middle part.